Guys, so let's talk about radical equations, section 5.8, radical equations. So a radical equation is any equation with square root or cube root or any root in the problem. So we have to use the opposite rule because it's an equation, and the opposite of square rooting it is squaring it. We also have things called extraneous solutions, and that's when you're all done and the answer, when you check back in, doesn't work. Let me give you an example. So we divide both sides here by -6. Divide by -6, you're left with x squared, and it ends up being 4. You square both sides, the opposite, and then we end up with x equals 16. Check it out, and it works. You can check that number and put it back in, and everything works perfectly. It all checks. 16 works when you plug it in. -6 times square root of 16 becomes -6 times 4, which is -24, which is the answer. Let's see what happens when we get an extraneous. So square root of a plus 9 equals 0. First thing you always do with these is you got to get the radical alone. We got the radical alone by subtracting 9. At this point, I want to square both sides again. You got to be careful. You got to make it a equals the square root. Not the square root becomes -9 to the second power, which is 81. Let's check 81. When you check 81, you get the square root of 81 plus 9 equals 0. 9 plus 9 equals 0, 18 equals 0. It doesn't work. That means this answer is not correct. It is extraneous. Extraneous. All right, next. Here's the steps. So we have the square root of g plus 1 equals the square root of 2g minus 7. Step 1 is get the radical alone. This is a special one because the radicals are already alone. Step 2, square both sides. Solve it, and then check. This is special because if the squares are on both sides, watch this awesome thing that happens. You square with a 2 and a 2, square and a square, and look what's left, a regular everyday equation. G plus 1 equals 2g minus 7. G equals 8, you check it, and it checks. It checks out. That is the correct answer. Now it's time for what I like to call the long problem. These problems are long. Whenever you have two radicals with number at the end. Now watch, you square, but it's not that easy to square the right side because the square root of b plus 6 minus 1 squared, you have to FOIL it. The left side's easy. The right side, you get this wicked long thing when you square. Square root of b plus 6, square root of b plus 6 is square root of b plus 6 squared, and then you got to do -1 square root of b plus 6, -1 square root of b plus 6 minus plus 1. You got to keep going. Canceling out that, combining the -1 and the -1, making it -2b. This is so long, and I gave it in class. I like timing this, and this could take between 2 to 4 minutes. That's me. Imagine if it was you, and you were doing all this process all the way down. You're squaring it again. You've never done one of these. Look at this. I'm at 4 minutes, and now we check. Look at the check. Do the check, and it takes even more time. Look, I'm still writing. This one takes forever. Just to be clear, look how long this slide is. Look how long it takes to get to the bottom of this slide. It takes forever. So these problems are really tricky, but this is all about the art of learning how to square, how to solve the radical equation by squaring. So, a couple things I want you to know also. If you ever see v to the second 1/2, it's really the square root of v. Same thing we've been doing, but they do throw little curveballs at you. Also, what happens when there's a cube root? Notice how the index goes on the outside and the top number goes on the inside. What if it's a cube root? Same thing, but it's a 3 on the outside. And when you go to solve, you can't square everything. What do? You cube it. You still get a good answer. It ends up being t. So 5/2.